So let's get started, guys. Right. So Pandas is a library, or it is one of the most common library. If you search for what is the most common library which is being used these days, so based on Stack Overflow uh, searches or searches in Google, it is one of the top three. So Pandas is one of the top three libraries which is being used or searched for in these developer forums. Stack Overflow being one of them. So yeah, so we are going to use Pandas. What it lets you do is it lets you actually manipulate the data, right? So Pandas is used for manipulating the data, manipulate the data, right? This is what it is primarily going to be used for. And what all comes when you talk about manipulation, right? So you'll need to, when it comes to manipulation, you'll need to slice and dice the data, right? And we'll talk about what is slicing, what is dicing, slice and dice the data. So some of the things that you will need to do when it comes to manipulation is you may need to look at the summary of the data, right? Or you can say you would want to look at the aggregate of the data, right? That's something that you would want to do. Now, what is the summary? It could be maximum, it could be minimum, it could be median, it could be mode, or it could be other statistical measures, which is standard deviation, right? So we will look at it as to how do we do all of this, and this is something that you would want to do. Now, what are the other things that you would want to do? And we are talking about the manipulation, right? What are the manipulations available inside Pandas? What all you will need to do? So when you have a data, you will need to manipulate the data. And one way to manipulate the data is to look at the summary or aggregate. And these are the measures actually. Now, what else you would want to do? You may want to cleanse the data, right? You may need to cleanse the data. Why you would need to cleanse the data? Because the data that you may get may not be clean to begin with. Now, what are the examples of cleansing, right? And what do you mean by the data that you get may not be clean? We are going to look at all of these examples, but just giving you a pre-cap, right? So you may have a lot of uh, NA values, right? Not available values or null values. That is one thing uh, that you may that you may encounter. You may also have uh, values which are uh, otherwise correct looking values, but then they may not be actually correct, and it may be a result of a typing error, or it could be because of any capturing or a data gathering error that it may result into such errors. So let's say age value, right? Age value, if I say someone has a age of uh, minus 10 years, you will straight away say that this is not possible, right? Or maybe age value of greater than 250. Now this is also not possible, right? I mean, theoretically possible, but then we have not seen these huge values of age for a human being, right? So if that is what is encountered, then this data is definitely not uh, clean, and then we may need to actually clean it, right? And why do we need to clean the data? We may need to clean the data because if you do not clean this, then any analysis that you do on a data which is otherwise wrong, all the analysis is going to be incorrect as well, right? So you'll need to first cleanse the data, and this is where this is one of the manipulations that we do using Pandas. The third one is you may need to do sort of other activities, like you may need to sort the data, right? So sorting we all know, right? We are going to look at it. Sorting is like if it is number, then it'll you will want to sort it from minimum to maximum, or vice versa, right? Sorry. So this is one way. And if it is alphabetical, then you would want to sort it alphabetically. So these are the two ways you can sort the data. It could be alphabetically ascending or descending. And same way you can do min to max or max to min, right? So this is another manipulation that you may need to do. The fourth one that we are going to look at is we may need to at times group the data, right? So we may need to group the data. So grouping is where you would want all the gender values to be grouped together. So it could be based on any categorical value. So it could be gender, it could be city, it could be country, right? So all of this comes under grouping. And then we will the last thing that we are going to do, and which is something which is an extension of number one, is uh, this is something which is going to be an extension of number one, is we will see some summary statistics to understand the data more. So we will look at summary statistics, and this is going to be number five, but then this is an extension of number one. So all of this is what we are going to do using Pandas, and that is why I said in the very beginning that Pandas is one of the most used libraries these days. One of the most used libraries. And when I say one of the most used libraries, uh, I'm not only talking about Python across all languages, right? And this is in top three actually. This is one of the top three libraries which is being used uh, right now. So enough of summary as to what we are going to do using Pandas. Let's see how we can actually use Pandas, right? Uh, and then you may have uh, questions there. So the first thing that you need to do is you definitely need to import pandas, right? So ideally to import pandas, you can write import pandas, and it comes as part of your basic package. So if you have Anaconda installed, then pandas is by default part of it. So you don't have to worry about it, worry about installing it. But what we usually do is we specify a alias name as well, right? So why do we specify the alias? So that we can use the short name later on, and this is what we have done here. So import pandas as pd, which means pandas is imported, but it has been given a alias name pd, and that is what we are going to use going forward. Now to manipulate the data, right, this is what we see. We're going to manipulate the data using pandas library. But then to manipulate the data, first thing that you need to do is you need to get the data. You will need to load the data, and that is what we are going to do right now. So what we are going to do right now is we are going to load the data inside a data frame, and then we are going to actually manipulate the data. So how do we get the data file? Now what I've done here is I have put in a GitHub link, right? A GitHub link, and this link looks like a complicated one, but you don't have to worry about it. This is just a URL. It starts with HTTPS and then ends with titanic.csv. So what we are trying to do is we are trying to load this file, right, which is a CSV file, and this is available on GitHub. So why I have included a GitHub link is if you run this code on your own machine, then you don't need this CSV file separately on your machine. Since this is a URL, this is a website URL, the same code will run on your PC as well, because the file, the titanic.csv file that this is trying to import, actually resides on GitHub, and this is, since this is a public URL, it will work for you as well. The other thing is you can save this file locally on your machine, and you can actually load it that way as well. So I'm just going to show you both the ways, so that if you have a local file, then you can open that as well, right? So I copied the content of this, and I am going to open Excel, and I'm going to, okay, there's a problem. There is a problem.
Just do text column.
Sorry.
Copy and just do text column.
Right, so I will need to do data text to columns.
No, no, you just select column A.
Just
Column, not column A.
yeah,
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 now.
correct. So delimiter, the delimiter is going to be, I I don't know,
Tab,
space.
tab, not space.
So I think it is space because now it is working correctly. No, tab.
Uh, it is not in correct format, correct delimiter. So we have to fix the length, I
Tab,
suppose.
right? This is tab. This is tab actually. You're correct. This is tab because in our this code, what we are doing is we are specifying the separator and separator is tab. So let's try tab here. So we have specified tab. No, not space because it is then breaking the name as well. Yeah, yeah, no space. Yeah. So this looks like correct, but it did not do anything.
Yeah,
So this is space. It is taking, but
space will
then
not work. Space will.
yeah, because it is actually taking the salutation as sex, gender, and age is also not a correct value. So
So
okay.
just paste it in the notepad and then you can
Uh-huh,
change.
sorry.
Just copy paste in the notepad.
Yeah, let's try this. That is what I was trying to do as well. Uh, and then let's cut it. Let's paste it here again. Yeah, so looks like this is fine now.
Not working.
No, no. So let's do one thing. This is a tricky file to deal with. So what we will do is let us try to let's try to download it from the
Schedule.
yeah, we can download it from any of the online sources, right? So training set gender test train. So train.csv, download all. So this may have done the trick. So what we are trying to do is we are trying to download this. Okay, yeah. So this is fine now. So what we have done is we try to download it from a location. So this is train.csv, and let me just close this now because we don't need this, and it must be in my downloads folder. Train, yes. Okay. So what I will do is I'll just cut this and put it in my E drive, device Python. Okay, right. So I have this file here, right? So now what we need to do is we need to actually import this file. So this is not required, this is not required. So there are two ways that we can actually import the file, right? You can import the file from a URL as well, and this is what we are trying to do. So do not worry about the long URL. This is the same URL that we have here, right? Open in the browser. So what is happening here is all of this data, which is available as a CSV file. That is what we are trying to import here. Now, how do we import this? There's this function called read underscore CSV, and we have specified the name of a data frame, and that is what is happening here. So whenever you do pandas, which is pd dot read underscore CSV, you need to specify the location of the file. That is what we are doing, right? So this is the location of the file. This file resides on GitHub, and that is what we have specified here. And then the second parameter that we have specified is what is a separator, right? So what is a delimiter, right? So if you look at that data file, the delimiter here is a tab character, right? Although this is not visible, tab is not a visible character. The delimiter here is a tab character. So all the fields are separated by a tab, and that is what we are specifying here. So when we do this, I'll show you what happens. So when we do this, nothing happens here, right? But what has happened is you have created a variable named Titanic. So the first thing that we will do is our favorite command, type of the data set and see what it says. It says pandas.core.frame.dataframe. So one thing is for sure that whenever you read a CSV using pandas, it creates a data frame. Now, what does a data frame mean? A data frame is nothing but, and we have defined this earlier as well, when we print this data frame by just writing the name of it, you will know what the data frame is actually going to be. So when you look at this data, right, this data has these column headers, and all of these are rows, right, for each of these columns. And in total, we have n number of rows, right, that we are not really worried about right now. So this is the passenger ID for the first passenger, this is the passenger ID for the second passenger, and then this is the these are the values of the survive field, and these are the values for the name, right? So the same thing is happening here. Actually, when Pandas is reading the CSV, it is creating a data frame, which means that it is converting all the data which it is reading into a table, into rows and columns. And this is what is happening here. This is what we can see when we print the Titanic variable here, which is a data frame. So see, all of these column headers are actually shown as bold text, right? So passenger ID survived, P class, name, sex, which is a gender, age, and then some of these column headers may not make sense to you, but then that is all right. We don't have to worry about what means which column means what, but then most of it is something that we can actually still figure out, right? So fare is the cabin number, and then there is a field called embarked. So all of these values are getting populated inside this data frame. So this is how you create a data frame. We have already seen an example where we created a dictionary and then we converted that dictionary into a data frame, right? We have seen that earlier. Here, we are reading a file directly into a data frame, and this is going to be much easier. I mean, there's just one command, right? There's one function that you need to call read underscore CSV, and then it is creating that CSV. Now I'll show you one more thing here, right? And that is going to be a variation of it, right? So you may this command is definitely going to work for all of you, but then what if I have the file locally available with me, right? So what if I have the file which is locally available with me? How do I open that? So that is also totally fine, right? Train is available in my E drive, and in my E drive I have a folder, right? I'll need to specify the whole folder name, right? So this is the folder structure. I will need to specify the whole folder structure. So let's do that. The only thing is that for uh, forward slashes, you'll need to specify two forward slashes in the path. And then you need to specify the name of the file. So train.csv. And let's call this Titanic 1, right? So that we have a different variable name. So see, this is also working, right? And when I'll not do a type because we know for sure that this is of type data frame. But then when we do print Titanic 1, then this is also printing the same stuff. Now, when you look at it, the number of rows and columns are also getting printed, and this is different. This value is different than this value. Why so? Because my both the sources are different, right? Now, this source is from this GitHub location, and if you look at it, this location has actually 156 rows and 12 columns. But when you look at this file that we downloaded from Kaggle, right? When you look at the end of the file, it has actually 891 records. So both of these are getting read properly, right? Getting the difference? So if you look at it here, the first one which is getting downloaded from GitHub has 156 rows and 12 columns. The second one, which is being read from my local repository or local file system, which I downloaded from Kaggle actually, right? It has different number of rows and columns, right? So that is why you are seeing a difference in the number of rows and columns, right? So this is how you actually create a data frame. This is very simple, read underscore CSV. Now there are a few other variations of the same command, right? And this is going to be very easy. Let's say in case instead of a CSV, you have a Excel file. Then what do? You can just write and use this command. I'm just going to comment this, but then in this case, what you can do is if this file is XLSX, right? Excel file or XLS 2007 above earlier, then you can actually use the same function, but then the name is slightly different, read underscore Excel, right? And then you need to specify a Excel extension. So this is also something which will actually read the data from an Excel file, and it will create a similar looking data frame. So enough of how to create the data frame and what a data frame is. Let's get into how to use the data frame, right? And how to actually do the different manipulation activities. So what we will do is we will continue to use a smaller data set, which is Titanic one, right? Which is actually getting downloaded from this location. And guys, when you download when you actually run this code, you will need to actually change the path from your local machine. And what you can do is, let me specify the location of the file from where you can actually download the file. Uh, File download location, and this is the location from where you can actually download the file. So this file, you'll need to go to this location and you'll need to download this train.csv in your local file system, and wherever you save it, you'll need to specify the location of that path, right? So okay, I'm not going to use this. I'm going to use the first one which I downloaded from GitHub, right? So that your code, if you run it from uh, without, and if you do not want to download the file, and if you still want to run the notebook, your notebook will continue to work. Okay, all right. So when you download the data set, what you are seeing is that this, since the data set is pretty huge, you are not able to actually look at the whole of the data or any targeted part of the data. So what you can do is you can actually look at the targeted part of the data by using these functions. So the first one is called head, right? So Titanic.head, and then what it does is it prints you the top n number of records, and what is n here, you can specify the number of records in here as 5, 10, 15, whatever you want, right? So let's say you need to see just the top three records, the first three records rather, then it is going to show you the top three records. And this is how you do your exploratory data analysis, right? So you have loaded a file, you have created a data frame, and you want to quickly look at some of the records, right? So that you get an idea as to what the data, how the data looks like. Then you can actually quickly do all of these, right? So head 3, head 5, whatever you want, you can do that. So this is actually printing your first 5 records with index 0, 1, 2, 3, and 4. The same way, if you want to look at the records from the bottom of the data frame, then what you can do is you can do tail, right? So all of these names are pretty self-explanatory. Head is for top, tail is for bottom n number of records, right? So you can do whatever. If you want to see bottom 15, this is going to show you bottom 15. If you want to show uh, 5, you can do 5. You can do 1. You can do 2. You can do anything, whatever you want. So this is how you actually print the uh, number of records, right? Let's say there is a need, right, and you want to actually look at 11th to 15th record, right? So I want to see 11th to 15th record. So in that case, what you can do is you can use a combination of head and tail, right? So 11th to 15th, right? So first we will pick the top 15th records, right? The first 15th record. And in these 15 records, if you look at it, the bottom five are the ones which will be at position 11 to 15, right? So we can use head and then you can use tail 5. So when you do this, then actually this is going to print you 11th to 15th record. So head and tail, they can be used in tandem as well. There is no problem. You can use them together. So head 15 would give you top 15 records, and from those 15 top 15 records, it is printing you the last five records. And this is what is happening: 10 to 11, 12, 13, and 14. So this is going to give you 11th to 15th record. Clear? Any questions so far? Do let me know.
No, Manish.
Okay, all right. So let's continue then, right? Let's continue and let's see what all other things that you can do, right? So one thing that you are actually already aware of is that the moment you print the data frame, it at the end of the right, the moment you print the data frame by just writing the name of the data frame, at the end of the data frame, it gives you the rows and columns. But if you want to print the rows and columns, and if you want to know how many rows and columns are there, then you can also use the shape function, right? Or shape variable. So it gives you number of rows followed by number of columns. So this is very simple. If you want to know quickly what is the shape of my data, by shape it means the number of rows and number of columns. That is what shape means. So the first one is rows and the second one is columns. The other thing that you would want to know, and this is where we are now getting more closer to the data fields, right? Every field, if you want to analyze every field, right, as to what is the data type, how many null values are there, how many non-null values are there, then you can actually do a little more. Uh, if you want to do a little more analysis, then you can use actually this function named info, right? So titanic.info. So when you do titanic.info, it is actually printing you a little more detail about each and every field, right? So these are the column names. These are my column names, right? And in each column, you see what we are trying to print. We are trying to print non-null count. So how many values are not null, which means how many values are legitimate values, right? So how many rows we have? We have 156 rows, right? And when you look at it, passenger ID says non-null count is 156, which means we have passenger ID available for all the rows. This is what it means. We have survived value available for all the fields. Sorry, all the rows. We have name available for all the passengers. We have um, age available only for 126 passengers, right? Which means for 30 of the passengers, age value is missing, and we will see how we can actually verify this. And if you look at this field here, right, it means that cabin information is not available for a lot many people. Only 31 people have their cabin information available, and embarked. If you look at embarked, then one value is missing there, in one of the rows. So looking at this field, right, and this command, you can actually know a little more about the the cleansing how clean is your data, right? The cleanliness of the current data. So why this is important is because if you need to do some analysis on age, then you'll need to figure out how do you handle this. You'll need to first handle this before you can actually do any analysis on age. But if you want to do any analysis on survive field, then there is no problem, right? All the values are available and there is no problem with the survived field. Now the other field, if you look at it, this is the data type, right? So it actually tells you for each column, what is the data type, right? So passenger ID is an integer number, right? If you look at most of these column data types, they are either integer or they are object. So there is no string data type in Python. And if you have a string value, then it actually shows up as object. So this is nothing but object is nothing but string or alphanumeric value. Age is a float value. Now this is interesting, right? Some of the age values are decimals as well. Fare can be float, right? So that is fine. So float, age, and fare are float, and then the others are either string or integer values. So this is the kind of information that the data frame dot info function gives you. So this gives you, definitely a count of the null and non-null values, and that is something that we can actually uh, use. It also gives you one more information, right? If you see this memory usage, 14.8 KB, right? So it is actually telling you that the size of the data frame is 14.8 KB, kilobytes. And this is B, capital B, bytes, not bits. The same information you can, if you really only want to look at the data types, you can do data types or data frame dot data types, D types, and then this is going to give you the same information which is available in info as well. So if you want to look at only the data types, you can use D types. Now, this is Titanic train dot size. So what this is actually giving you is the size of the data set, and this is nothing but rows into columns. May not be very informative, but then this is also available. Something similar to shape, right? Yeah, something similar to shape. So shape gives you number of rows and columns, which is more informative, and size gives you a multiplication of both of these. Uh, so basically, it gives you what is the size of the table. So if it has 3 rows and 10 columns, then it will give you a size of 30. Now, this is going to be interesting, right? So there is a function called, or there's a function called describe, right? Now, what it does is it gives you summary statistics of uh, l- a- or and a lot of information, not just summary statistics, but then a lot of information about all the numerical fields, right? So what does describe do? If you look at it, it is giving you some information, but then is this all is are these all the fields? Not really. Where is the name field? There is no name field here, right? Where is the sex field, right? Which represents gender, which is a object field. So it is not there, right? So if you look at it, what is happening is describe gives you summary statistics for all the fields which are either int 64 or float 64. That is it. Fair is the last one, and then the first one is passenger ID, right? Do you see name? Do you see sex? Do you see ticket, cabin, and embarked? All of these
No.
are not going to be available, right? So the first thing that you should note is that data frame dot describes gives you summary statistics data of all the numerical fields. You can generally say all the numerical fields, right? Even date or boolean values will not have a summary statistic. All right, so moving on, right? Now let's look at something, one of the columns and try to make sense out of what is happening here, right? So one thing which will make a lot of sense to us is a fair field, right? Or maybe a age field. So let's pick fair first, right? So what it is telling you is that the count of fair values is 156, and we know that the number of rows is 156, right? So fair has total count of 156. How many fair values are available? 156. Now, what is the minimum fair, right? This column gives you the minimum value. What is the minimum fair available? This is 6.75, right? Uh, and you don't need to worry about the currency here, but then whatever currency it is, the minimum fair value is 6.75 in that field. What is the maximum value? What is the maximum value? The maximum value is 263. It could be dollars, it could be any currency, right? So we're not really worried. So we could easily figure out what is the count of the values, the minimum of the value, the values and the maximum, right? The other thing is mean, and mean is nothing but the average, right? So what is the average of the all the fares? So the average is 28.109587, and then there are a few other things that we will need to actually discuss a little more to understand. We have STD, which is standard deviation, and we have 25%, 50%, and 75%. So we will see as to what these are right now. So let's get into any questions you have on count, mean, minimum, and maximum, because I think these are going to be very simple for you to understand. The other ones, I'm definitely going to explain standard deviation, 25%, 50%, and 75%, which is a little tricky to understand, right? You guys are good with minimum,
Okay.
maximum, mean, and count?
Yeah.
Okay, all right. So let me give you an idea of how to understand these values: 25%, 50%, and 75%, and then we will come to standard deviation. So before that, although the summary statistics data that described does not give you any idea about median, what do you guys understand by median, and how is it different from average? Anyone? How is median different from how is median different from average? So let's say we have some values, right? Let's say we have some values, right? We were talking about fair, but then to take this example, what we will do is we will actually look at a few random numbers, right? And what I'm going to do is I'm just going to arrange them, in an order. So what I'm going to do, I'm going to actually take random numbers, right? So I'll take 5, take 7, 12, 15, 16, 29, 30, 35, 36, 39, 50, and 55. How many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 13, 15. So total 15 numbers are there, right? What is the count of numbers? 15. Now, what is the average, right? Or what is the mean? What is the mean? The mean is you add all the numbers, right? You sum of the numbers, sum of numbers by the count of numbers, right? So the count is definitely going to be 15, and let's not do the maths here, but then let's say if it is 250, definitely more than that, maybe 350, then this is going to be 350 by 15, whatever it comes out to be. This is going to be my median, sorry, mean, right? But what is my median value? My median value will be and what we can do is actually we can quickly do the maths here so that it becomes more uh, meaningful for us, right? So 5 plus 7 plus 12 plus 15 plus 16 plus 29 plus 30 plus 35, 36, 39, 50, 55, 60, 65, 66, right? So this is 520 actually. This is 520. 520 by 15. So this is 34.66, right? So this is 34.67, I'll say, right? So this is my mean. Now, what is my median? What is my median? Anybody?
Yeah,
Median is
mid value.
the middle value, right? So what is my middle value? Since my count is
Is
18,
15, then the
Eight
uh,
number.
8 1, right? So 1, 2, 3, 4, 5, 6, 7, 8, right? So this is the eighth number. So my median is the middle value, right? But then you need to actually make sure of one thing, right? You first need to sort the list. So you first need to sort the list, right? And in my sorted list, 35 is the middle value. So that becomes my median. So my mean or average, this is average, right? This is mean. We also call this as average. And this is my median or the middle value. Now, why are these numbers so important, right? These numbers are so important because they represent, we call it the central tendency of the number. Central tendency. It represents a central tendency, right? And it is also called as a measure of central tendency. Now, why this is important is because if you are given multiple numbers, right? If you're given multiple numbers, then how can you actually study them, right? You have 15 different samples here, right? Of anything, right? Any variable. Now, how can you actually make sense out of it, right? The first thing that you can do in statistics is you can look at the ma- central tendency. Okay, I have all of these numbers, but where are the numbers centrally headed towards? And that is what we do when we create the mean. So when we create the mean, what we are trying to do, we are trying to figure out where the numbers are centrally headed towards. So these numbers has a tendency of heading towards or moving towards 30, this number 34.75. And that is what this means. Median is the middle value. Here we do not do any calculation. What we do is we just look for the middle value. So if you have 15 elements or 15 samples, then what we do is 15 plus 1 by 2, which is 8. So eighth number from any side will become your median. And if you have, let's say, 16 numbers, then what we do? Then what we do? The middle two numbers, right? Middle two numbers, right? In this case, the seventh number and the eighth number, right? We will need to take the average of these two. And that is the only possible option that we have, right? So we can actually do a average of these two. That is what we can do, right? So this is only when, and that is why I actually took a odd number of samples, the odd number of count. So these are mean and median. Now the other two other concepts that we were looking for is what is my 25%, 50%, and 75%. So to understand this, we need to again look at this number line, right? So this is my median value, right? So if this is my median value, then can I say that now this median is using the median, I'm able to divide this list into two different lists, right? So this is my first list, this is my first list, and this is my second list, right? So this is my first list, and this is my second list, right? Of numbers. Now, if you consider these separately, right? It has 1, 2, 3, 4, 5, 6, 7, 8 digits, and then this is my 1, 2, 3, 4, 5, 6, 7, right? So what will happen is now if I again try to calculate the median, right? Somebody will need to mute. I think there's a feedback. Yeah. So now if you want to, that's good. Yeah. Thank you. So now when you look at these two lists, and if you still again want to try and calculate the median, right? So the median for this list is going to be the average of 15 and 16. So 15.5 is the median, right? And here the median will be this number, the middle number, which is 55, right? So now again we have two different medians. So this was the median, and then we have two different medians again from the both the lists. So the way it works is now this will be referred to as 25%. This will be referred to as median, and this will be referred to as 75%. We can also call it as 50%.
So median is 50%. Okay.
Median's 50%, right? So now when you look at, when you go back and look at this, if it is saying 25%, then it is trying to figure out what is that median from the first half of the list and what is that value. This is what it means. So 50% is, now you know what it is, right? 50% is the median value. So in this list, your 35 was the median, right?
And
So
that
if,
is
yeah,
important.
so if you actually look at 50%, this is going to be 35. This is what it means. So basically here you can say that 50% is nothing but the median, and that is what it means. Sure. Yeah. So this is my 50% is nothing but the median. Now let's look at the other ones, right? 25% is now the median from the first list, right? So what is my 25% now? My 25% is 15.5. And what is my 75%?
55,
75% is
55.
55, yes. And if when you look at it, there is no 100%, right? Because 100% is my maximum and 0% is my
Minimum.
minimum, right? So now if you look at it, this is in an order, and that is the reason. This is 0%, this is 25%, this is median 50%, 75%, and maximum is 100%. So there is no 100%, there is maximum, which is 66. There is minimum, which is 5. And this is what actually that table shows.
So this is the reason we have to show the list first, and then we can calculate the median.
Yes. Uh, so in Panda in Python you don't necessarily need to show the list, right? Because if you are calling it using the data frame, it will just calculate it. I'm just trying to show this to you so that you can actually understand how all of these values are getting calculated.
So that's the background process of Pandas library to show
Yes.
the system.
Yes, yes. So what it is doing, right? If it is showing you a 50% for fair, then actually it is arranging all the fair values, all the values of fair, starting from the minimum value to maximum value, and then it is showing you the middle value. And this middle value is nothing but 14.45. And from the first list, the middle value is going to be 8. From the second list, the middle value is going to be 30. And that is what it is doing.
Right.
Got it?
Yep.
Yeah. Standard deviation is a little tricky concept, and then we will tackle this later. But then, if you look at the rest of the list, we have done pretty much everything. Now, there are a few other names of this, right? This is also called as 25%, 50%, and 75%. This is also called as, you may see somewhere written as IQR, intra quartile range. So let's just finish this intra quartile range. And specifically 25% is called Q1, this is called Q2, and this is called Q3, or it is also called as I. There are many names to this, right? Quartile 1, quartile 2, this is called quartile 1, quartile 2, quartile 3. It is also referred to as IQR1, IQR2, and IQR3. So whatever you encounter, you don't have to actually worry about it. All of these mean the same. And in as a unit, they are called IQR, intra quartile range, right? So why quartile? It is actually divided into four quartiles now, or quartiles now. This is IQR1, this is IQR2. So this is going to be your IQR1 from here till here. This is my IQR2 from here till here, and this is my Q3, this is my Q4, right? So this is how you can actually understand the described table, right? We will tackle standard deviation later. This is going to be a little tricky to understand, right? So we are just leaving this for now. Now, what are the other things that we can do? And then, guys, the describe is very powerful function. It reveals a lot of information about all your numerical fields. So next time, whenever you look at it a little more objectively. Except for standard deviation, we have covered everything. And then, if you look at it a little more objectively and understand it from the number line concept, which is a sorted list, then this is going to be much easier for you to understand. So moving on, any questions with describe before we move on?
Yeah. Can you please go back on the whiteboard?
Yeah, sure.
Can you please little bit more elaborate on central tendency?
Right. So what happens is when you have to so what is the statistics, right? Statistics is nothing uh, but the study of numbers, right? And a study of numbers, when you're doing any study of any numbers, then what are these numbers going to be? To give you a little example, this could be possible values of age for, let's say, 1,000 people, right? That is one set of numbers that you may get, right? You may get, so this is age, right? You may get marks. If you're looking at students information, then you get marks, right? It could be n number of students. So that is another thing, right? Then you may look at salary information if you're looking at employees, so n number of employees. Now, what will you do with these numbers? Let's say you have salary information of 1 lakh employees, right? What will you do with this? How can you understand this number? So what happens is, to understand this number, you need to summarize this, right? These numbers. And how do you summarize the numbers? So the very first summary that we have been doing since ages, since I'll say maybe standard third or fourth, is we calculate the average, right? We calculate the average. What do? We add all the numbers,
Divided by the count of number.
right? We do all of this, and then divide by count, right? So what are we trying to do here? Why are we even calculating the average? Just think of it this way. We have a million numbers, right? Or we have 1 lakh numbers here, salary information. And it is not any informative as such. When you look at these numbers in isolation, this is not informative at all. But when you calculate the average, suddenly you only have, let's say, a single digit number, let's say 50,000 is what comes out of it. 50,000. Then suddenly this number starts making sense. Why? Now, because we are dealing with a small set of numbers, right? We are only dealing with a single number. And what does it mean? If every employee was given the same salary, then what that salary would be? 50,000.
50,000.
Now, suddenly, what does it mean? Why will, so not everybody is going to get the same salary, right? This is not going to be true. But why do we even do this calculation? We do this calculation to find out what is my per employee cost. And why do we do that? Why do we do a per employee cost? Because if, let's say, we will need to double the size of the company, right? If we need to double the size of the company, then what is my expected salary expense going to be? Can I safely assume that this is going to roughly double? Because when you hire people, you will hire people at every level, right? You will hire managers, you will hire mid management people, you will hire junior folks, you will hire interns, you will hire people at the all the levels. And chances are that their average salary will also turn out to be similar to what it is. So if you have to double the employee count, then calculating the salary expense of my new company size, you can simply multiply this by the new strength or number of employees, right? And that way you can get the projected expense that you may incur on the salary. So that is the reason we calculate average. And if you objectively look at it, when we calculate the summary, then this number, whatever you calculate, right, is always going to be somewhere in the middle of it. This list, this sorted list. So somebody will have a salary of 25K, somebody will have a salary of 35K, somebody will have a salary of 65K, and somebody may have a salary of 200K, right? So all of these are different salaries, but where is the middle salary, right? Maybe somewhere around, I don't know, 80K is where the central number would be. So what it may mean is that, eventually, if you look at it, what is the per employee cost, then that is maybe turning out to be 80K. And this is just hypothetical. I have not calculated it, but then this could be hypothetical. So measure of central tendency is to look at where the numbers are centrally trying to move. And one such measure is average. What happens suddenly, let's say if you hire a lot of junior folks in your company, let's say you hire a lot of junior folks or interns, what will happen to my average salary? Will it increase or decrease?
Obviously degrees.
It will decrease, right? So now the central tendency of the salary has moved to the left side. But if you hire a lot of senior folks, then the chances are that the average or the central tendency of the salary will move
Increase.
to the right side. It will increase, right? So that is why it is called measure of central tendency. And there are
So,
two measures of central tendency, average and median. Yes.
so that's why average is the most important function when we do statistics of large data set and all, right?
That is what, right? It's just that when we were taught all of this, we were not, you know, told specifically as to why do we even calculate this, right? We have been calculating average as I mean, more than doing sum and count, we have been doing averages, right, since ages.
Yeah.
But then it's just that we were never told or specifically uh, categorically told why do we even or what does it represent, right? And why do we even calculate this? So that is the reason. It is a measure of central tendency. So if you want to summarize the data, the first thing that comes to your mind is where the numbers are going to be centrally placed. The other thing,
Right.
which is standard deviation, is how spread the numbers are from the center, is what we study here. But then this is going to be a long discussion. We will do this later on. So moving on, right? The other things that we need to do here is, and these are going to be quick, right? So value counts, right? So when you do uh, specify any column name with the data frame and then do value counts, then it is going to actually give you counts of all the unique values for this field, right? So what we can do is we can, when you look at this, 1 appears 1 times, 2 appears 3 times, 3 appears 1 time, and 152 appears 3 times. So this is what it means actually. Uh, for each unique value of this field P class, how many times that value is getting repeated. And this is what it is actually telling you. 4 is getting repeated 3 times. So at times you may need to know if any value is getting repeated, then this is a function or this is the variable that you can actually use. The other thing is
Why
if
we
you
was
want, sorry,
square bracket use here?
sorry.
Why we are using square bracket here?
So why we are using square bracket here, this at this place?
Yeah.
Yeah, because what we want to do is we want to wait. So let me take another example. Let me take another example to first show you this. So Titanic and let's say name and dot head uh, 10. So what is happening? If I need to specifically refer to any specific field, right? So these are my field names, right? These are my field names. And let's say if I need to only manipulate on any specific field, then you can specify that inside the square brackets, and that is what we are trying to do. So when you do not specify anything inside square brackets, this is taking the whole of the data frame. But in this case, when we specify a specific field name, then actually it is only going to be concentrated on that field name, right? So Titanic name would mean I am only interested in the name column, and you can change this to any field, right? You can change it to what are the other fields that we have? We have survived, we have name, we have age. So let's change it to age. So these are my top 10 or the first 10 age values, right? So we are using square brackets to actually signify which field uh, you want to manipulate. So if you want
And
to
we are
manipulate any,
converting.
sorry.
Yeah. Sorry, basically we are converting the column into a list, right?
No, so right. So okay. I know where you're coming from now, right? So we are definitely not trying to convert this field into a list. Definitely not. Here, the square brackets is actually representing entirely different thing, right? Square brackets is actually being used to refer to any field of this data frame. It has no relevance to what we have seen in list, because I know what where you're getting confused from. So in the list, when you specify a list, specify the elements of the list inside big brackets, right, or square brackets. But
Yeah.
then that's not exactly what we are trying to do here. We are working with a data frame, and to to refer to any specific field of a data frame, we also use the square brackets, right? So Titanic age would mean the age field is that's what we are trying to refer to. Clear?
Yeah.
Same ways, there is a function called, and we have already seen this, right? V counts, value counts. So what we are trying to do, we are trying to actually look at the value counts of this field called P class, passenger class, and it is actually showing me all of these values. This is a value counts field, and this is my P class field. Okay, what else we can do? We can actually try and filter out all the data items with specific data types, right? So what we are trying to do, we have specified here Titanic. Uh,
What is Titanic train?
this is incorrect. I will change it. Yeah, this was a different variable when I was trying to build this, but then I changed it now. So what is it that we're trying to do? Titanic dot data types is equal to object, and then we are passing this inside Titanic dot d types. So what it is going to give you? It is going to give you all the data types, all the fields which has a data type of object. Same ways, if you want to filter all the in values or all the fields which only have which have int64 as data type, then you can do this. Now this is additional, guys. You can actually look at all of this here using d types only. So this is going to be much simpler. If you want to just use this is also fine. It is also very going to be very easy for us to identify the data types from here. And then you also have info using which you can do all of this. So this is additional. If you want to filter only specific data items, fields, then you can do that. Now, uh, this is going to be a little, specific commands for what we have already seen here. Titanic.describe gives you all of this in a beautiful table, right? So you have count, mean, standard deviation, minimum value, 25%, 50%, 75%, and max. But if you only want any specific field or any specific row, then that is also possible. How do we do this? You just write mean, and this is going to give you mean. So let's quickly verify this, right? So age mean is 28.141508. 28.1415. Age mean 28.141508, right? So it's the same value. So what it is giving you is, it is giving you the mean of the age field. And that ways, it is not just giving you mean of age field, it is actually giving you the whole, this row, only the mean row for all of these fields. So this is also possible. If you know exactly what you need, then you can put in that command as well, or use that function as well. So this is mean. The same way we have median. If you want to look at the median, you can look at median. And how you can verify this? This is going to be the same as the 50% value, right? So let's look at age 50%. What does age 50% give you? We saw it here, right? My 50% is going to be the median value, right? So let's look at age. Age median says 26. Then this should be my 50% value. See, right? So now this is all going to be more meaningful to you because we know how it is going to get calculated. So we can do mean, we can do median, we can do max. Again, this is not something which is difficult for me to understand, or you to understand, because you know how to match them. And then you also have minimum. When you look at minimum values and maximum values, you'll see that you will have minimum and maximum for these alphanumeric values as well. Now these are nothing but when you do maximum, the last value. When you do a minimum, then this is going to be your first value, alphabetically arranged value, right? So these are what you can do. Standard deviation is again going to give you STD. Standard deviation is going to give you the same values from the described table. It's just that we have not looked at how to calculate standard deviation, so it will not uh, make sense to you now. But let's quickly look at the value. So age as a value of 14.6138, right? 14 point age standard deviation 14.613880, right? So all of these are the same values from this. It's just that these are specific commands. When you want to do standard deviation, you can use these. So that is done, guys. Let's look at correlation. There is another function called correlation. So what do we understand by correlation, right? There are anyone wants to try and explain what is correlation? No? Okay, right. So correlation is nothing but have you ever used or have you ever drawn a scatter plot, right? Have you ever drawn a scatter plot?
Yes.
Okay, so if you have drawn a scatter plot, then what we try to do there is we want to see the relationship between two variables, right? So
Very right.
yeah, so there are two variables, right? There are two variables. Let's say uh, there is humidity and there is rainfall, percentage of rainfall, right? So what can happen is if you plot all the humidity versus percentage of rainfall values, then it may appear like this. And I'm just drawing a hypothetical value. These are not real values. So what it means, right? If you look at the trend of the trend of the data is upwards. What it means, if my humidity increases, the chances of rainfall is increasing as well, right? So
Mm-hmm.
if it is increasing, then this one is increasing as well. And this is pretty evident looking at these samples, right? So we say that this is a positive correlation. If my humidity increases by 1 unit, I really don't know by how many units my percentage of rainfall is going to increase. That is not what is evident here. But one thing is really evident is that if it increases, then if my humidity increases, then my rainfall is increasing as well. What are the other variations which can happen? The other variation could be for any other variable x and y, the other variation could be something like this, right? Where it is very evident that if the value of x is increasing, this is decreasing, y is decreasing, right? It has a downward trend, which means what? Which means what? It means that if one variable is increasing, the other one is decreasing, right? It could be any two variables. We really do not need to worry about. What we need are trying to look at is what is a correlation. So now this is a negative correlation. If one is decreasing, then the other one is uh, increasing. If the one is increasing, then other one is decreasing, vice versa. So negative correlation, right? And then we could have trends like these, right? Where you may not be able to figure out as to what is a trend, right? You may not be able to figure out. It is definitely not a upward trend. Is it an upward trend? Really don't know. Is it a flat trend? We really don't know. Is it a downtrend? We really don't know. All of these are questionable. So there is maybe these are not correlated. These two variables are maybe not correlated. So what happens here is, let's say if your humidity, right? If your humidity increases by 1 unit, and your percentage of rainfall also increases by 1 unit, then you say that the correlation coefficient is going to be 1,
Obviously.
is 1, positive 1. But in another example, if let's say if your humidity increases by 1 unit and that results into your percentage of rainfall increasing by 2 units, then you can say that the correlation coefficient is going to be 2 plus 2 in this case. Means 1 unit change in humidity is resulting into 2 units change in percentage of rainfall. So in this case, the correlation coefficient is going to be 2. And in this case, the graph will be not like this, it will be something like this. The correlation will be something like this. It will be very steep. So this is to give you the magnitude, right? This was just to give you an idea as to if there is a correlation, right? So in this case, there is no correlation. There is no correlation. This one is a negative correlation and this one is a positive correlation. So this was just to find out the correlation. But what is the extent of the correlation, right? If there is a correlation, then what is the magnitude of the correlation, right? How steep or how slant the correlation is. This is what actually is being shown in these numbers. And this is what I gave you as an idea here, as an example here. What is the extent of the correlation coefficient? And this CORR is actually giving you the correlation coefficient. So to put these into perspective, right, I ask you this question, right? On the Titanic, right, if there were 900 people who were traveling, and if I plot age here, and if I plot survived here, what will be the scatter plot look like? If my age increases, does my does it increase my survival chances?
No.
So that is what we do not know, right? That is something that we can find out using the scatter plot. That's something that is what I'm trying to say. So survival percentage increases or decreases. I really don't know. If it increases, the graph will look like this. If it decreases, then the graph will look like this. And this is something that we can find out when we do the correlation coefficient, right? So let's look at it, right? Now that we have a problem, let's look at these two. So how do we look at this? So look at age here and look at survived. It has a value of negative 0.12. Now, what does it mean?
That means survival photograph going to the negative, right?
Yes, so correlation is negative, which means if one of them will increase, the other will decrease, right? And so, which means that when you said that this trend is definitely not true, this trend is true. When my age increases, my survival rate is going to decrease. And this is going to be true. The trend is going to be something similar to this. The trend is going to be something similar to this. And the extent of the relation between these two is the magnitude is 0.12. So it has a 12% correlation, you can say. If my age increases by 1 unit, right, my survival chances will decrease by
One.
12%. Is 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 what this means, by the way. Or will decrease by 0.12. Correct?
Yeah.
Getting the sense out of these numbers? So when you
Yeah.
do the correlation next time around, right, look at this more objectively and then pick these examples, right? Um, and that is going to give you a little idea. You can,
So
so when
when
you,
we,
yeah,
yeah, please go ahead.
so this value, when you look at age and survived, this value, you will see the same value here as well, right? When you look at survived here and age here, it is the same value, right? So this value 0.12 minus 0.120416 and this value here minus 0.120416, these are going to be the same because these are the different ways of looking at it, right? Age and survived. We can look at survived and age here as well. So you can look at any of these places and they will be the same.
So can we get something do in detail, like correlations?
What do you mean? What you can do is
I mean,
you.
just like you draw the charts on the whiteboard,
Uh-huh.
so can we have the same kind of the trend we can show in graphically manner as well.
Yeah, we can do that now. So what you can do is you can actually use pandas, sorry, matplotlib to plot these, right? And if you have seen this video here, I have already uploaded one video for matplotlib, right? So when you look at
Yeah.
this matplotlib, it has an example of scatter plot as well. So
Okay.
when you look at it, you'll be able to plot the correlation metrics that we are trying to do here. So what you need to do is you just need to specify your x variable and y
And why?
variable, and it is going to give you a scatter plot of these two as well.
Okay.
So kind is equal to you will have scatter. So kind is equal to scatter and then x and y. So let's try and do this here. Scatter is why is this giving an error? So this is one command plot using which you can actually plot it here as well. Data or data frame x, label position x, y, kind x, y. Okay, so I'll need to check why this is not functioning. But this should work. Okay, now, right. So the problem is that we have not treated the data, and that is why it is not able to plot. The problem is the number of, there are a lot of non NaN values, right? Not available, not a number values, and that is why it is not able to actually plot them. But when we actually correct them, we will be able to run this command. The same command will run, and it will actually calculate this correctly. The problem is that one of the fields has 156 values and then the other one has less values in there. So this is the command we will be able to run titanic.plot and then kind is equal to scatter, which is the type of the chart, and then this is the x variable, this is the x variable, this is the y variable. We can do, right? Um, And before that, we will need to actually look at how to clean the values or how to replace the NaN values, which we have not seen so far. So for now, what I'm doing is I'm just leaving it as is, right? So that you guys know why this is a problem. We'll need to run it again once we clean the data, which we have not seen so far.
Okay.
Right. The other way is you can look at this recording, class recording from matplotlib, and you can actually use your matplotlib libraries to calculate these, sorry, plot these values. But for that also you'll need to first cleanse the data, right? Which we have not seen. So I'm just leaving this as is for now so that you guys can actually figure out.